Hello viewers, in today's class we are going to solve yet another important and conceptual problem from definite integrals, right? And here today we are going to discuss this integral that is from 0 to 20 pi, and we have a square root of 1 minus sine square x dx, right? Now here there are two important points, right? In order to solve this integral, we have to make use of two concepts, right? And the concepts are, the first one is the concept of periodic functions, right? Periodic functions. And the second one is the concept of absolute value function, right? Absolute value function. So these two concepts shall be used in order to solve this important definite integral, right? So let us start. Now here let us first take this integral as I, right? Now from trigonometry we know that 1 minus sine square theta is equal to cos square theta, right? Because sine square theta plus cos square theta is equal to 1, so therefore 1 minus sine square theta is equal to cos square theta, and this identity would be used here. So therefore this integral I can now be written as integral from 0 to 20 pi, and we have a square root of cos square x, right? Okay, so once we have written our integrand like this, now we can make use of the concept of absolute value function. Now we know that the absolute value function is defined as square root of y square is equal to mod of y, right? And here y is equal to cos of x, right? So now this integral can be written as 0 to 20 pi, and here we can write mod of cos x, right? So here we see that how we have converted this integral into an integral involving absolute value function. Now let us make use of the concept of periodic function, right? Now viewers, we know that the period of cos x, right? The period of cos x is 2 pi, right? And the period of mod of cos x, that is absolute value of cos x, is always pi, right? So these two important points are to be noted here. The period of cosine function is 2 pi, but the period of mod of cosine function is pi, and this would be used to evaluate this integral, right? Now see the period of mod of cos x, it appears in the upper limit, that is the upper limit is 20 pi, and here the period, that is period of mod of cos x, is denoted by t, then t is equal to pi, right? And we know from the properties of definite integrals that integral 0 to nt, right? 0 to nt of f of x dx is equal to n times the integral from 0 to t of f of x, right? So this property would be used over here, right? Here n is an integer, and here n is 20, which is a natural number also. So 0 to nt f of x dx is equal to n times the integral from 0 to t f of x dx, where t is the period of f of x, and here f of x is our function, that is mod of cos x, and the period of mod of cos x is pi, right? So now this integral can be written as here the value of n is 20. So now we can write it as 20 times 0 to pi, here integral from 0 to pi, and mod of cos x dx, right? So here we have seen how to simplify this integral using the concept of period of the function mod of cos x. Now let us concentrate on the limits, right? So here x varies from 0 to pi, right? So let us draw the quadrants here, and here we have 0 and here we have pi. So we have to go from 0 to pi, right? So when we travel from 0 to pi, we have to cross the first quadrant and the second quadrant, right? And from trigonometry we know that in the first quadrant all the trigonometric functions are positive, therefore the cosine function should also be positive in the first quadrant. And in the second quadrant we have a sine function as the only function which is positive, and the rest of the functions, that is the 5 functions, are negative in second quadrant. So here the cosine function is negative. So now this is an important concept here. In the first quadrant cosine function is positive, and in the second quadrant the cosine function is negative, right? And we have to travel from 0 to pi, right? So now what we can do, we'll split our integral as a sum of two integrals. That is, the first one is from 0 to pi over 2, and the second one is from pi over 2 to pi, right? So now we can write it like this. So we have 0 to pi over 2 and mod of cos x dx, and the second integral is from pi by 2 to pi, and here we have mod of cos x dx, right? So now we have to evaluate these two integrals. Let us call these two integrals as I1 and I2. So now from the definition of absolute value function, we can write mod of cos of x is equal to positive cos x and negative cos x, right? So mod of cos x is positive cos x whenever x it belongs to the first quadrant. It means when x belongs to 0 to pi by 2, which is our first integral, that is I1 from 0 to pi by 2. So mod of cos x is plus cos x, and mod of cos x is equal to negative cos x because we are now in the second quadrant. So x belongs to pi by 2 to pi, right? So here mod of cos x is equal to negative cos x when x varies from pi by 2 to pi, right? So now this integral I can be written as 20 times we have 0 to pi by 2, and here we have plus cos x dx, plus here we have pi by 2 to pi, and here mod of cos x is equal to negative cos x, right? So now we have seen that how we are simplifying our integrals using various concepts. So now we know that the integral of cosine function is equal to sine function, right? So the integral of cos x is sine x. So here now I can be written as 20 times, and here we have the integral of cos x is sine x, so we can write here sine x, and the limits are from 0 to pi over 2, and then we can take this negative sign here, and the integral of cos x is sine x, and the limits are from pi by 2 to pi, right? So now we have to just simplify it. Now we have 20, and now we can substitute the limits here, and we'll take the difference. So we have sine pi by 2 minus sine of 0, and then we have sine of pi minus sine of pi over 2, right? And from trigonometry we know that the value of sine pi by 2 is 1, sine 0 is 0, and here sine pi is 0, sine pi by 2 is 1, and now this is 20 times, here we have 1, here we have minus 1, and this is 20 times 1 plus 1, and this is 20 times 2, that is 40, right? So viewers, the value of this integral is equal to 40, right? And we have seen how to integrate this function using the concept of the periodic function and the absolute value function.